Welcome to The Explainer. Today, we are embarking on a really fascinating journey. We're actually going to master two seemingly unrelated but incredibly powerful skills. First, we're going to unlock the secret psychology behind capturing and actually holding human attention. And then, we're going to immediately use those exact psychological tools to demystify one of the most notoriously complex and honestly misunderstood pieces of technology on the planet. Okay, let's just dive right into this. So, quick question for you. Have you heard about the 70% rule? This is literally the ultimate curiosity loop, and it comes straight from the playbook of top internet creators. According to some fascinating research by content strategist Patty Galloway, the absolute best performing content out there shares one vital metric when it comes to keeping an audience engaged.
And that magic number is 70%. The most successful explainers, shorts, and presentations all manage to keep 70% of viewers from swiping away or just completely tuning out within the very first 3 seconds. I mean, think about that. You have exactly 3 seconds to convince a human brain not to go look for a dopamine hit somewhere else. So how do you actually pull that off? Well, you use a hook.
Section 1, Anatomy of a Viral Hook. A total masterclass in this comes from creator Calloway, who breaks down exactly why we pay attention to things. And spoiler alert, it's not about random yelling or clickbait. It's actually a highly structured formula that forces the brain to build a curiosity loop. Step 1 is the context lean. You establish common ground, tell the viewer exactly what the topic is, and get them to lean in. Step 2 is the scroll stop interjection. You basically hit them with a contrasting word, like but or however, to just stun their brain for a millisecond. It's kind of like a bird hitting a window. And then step 3 is the absolute haymaker, the contrarian snapback. You completely pivot their expectations, snapping them onto a totally different, unexpected path. So let me just show you exactly how this works in real time. We've been talking about the psychology of YouTube hooks, how to grab attention, and the 70% rule. But get this, the absolute best way to prove you've mastered communication isn't by talking about social media. It's by using it to explain the backbone of modern enterprise software. Bam! That right there, that is the contrarian snapback. We are officially leaving the world of hooks and we are entering the machine. Section 2. What is the JVM? So, if you've ever stopped and wondered how a single programming language can run on a Windows laptop, a Linux server, an Apple Mac, and an Android phone without changing a single line of code, well, the answer is a piece of absolute engineering magic called the JVM. The JVM stands for the Java Virtual Machine. And the absolutely crucial point to grasp right here is that it's quite literally a virtual computer running inside your actual computer. You see, when you like Java, it doesn't compile into code for Mac or code for Windows. It compiles into something called bytecode. The JVM then steps in and acts as the ultimate universal translator, taking that bytecode and translating it on the fly into the highly specific machine code that your hardware understands. This is the entire secret behind Java's famous write once, run anywhere promise. Here is how this builds a complete software lifecycle. Step 1, you write your Java code. Step 2, the compiler turns it into a .class file, which is that universal bytecode we just talked about. Step 3, the JVM steps in, loads that bytecode up. And finally, step 4, it executes it as native machine instructions. So without the JVM, Java's really just plain text. But with it, Java is a cross-platform powerhouse. Section 3. Inside the virtual machine. To really understand this, let's pop open the hood and use a technique called cult hopping, which is basically taking a complex unknown and wrapping it up in a super familiar concept. We are going to explore the architecture of the JVM by comparing it to a high-end commercial kitchen. The JVM fundamentally has 3 main components. First, the class loader, which acts like our kitchen organizer. Second, the runtime data areas, which act as our pantry. And third, the execution engine, which is our chef. Let's break down exactly what each of these stations is doing to cook up your software. All right, first up, the class loader. Think of this as the meticulous librarian, or the incredibly strict organizer of our kitchen. Before any code can actually run, the class loader has to go out, find those .class files, load them into memory, and strictly verify that the bytecode is entirely valid and safe. It links everything together and initializes the static variables. Basically, it makes sure the kitchen is fully prepped and ready for action. Next, we move over to the runtime data areas. This is our pantry. This is exactly how the JVM manages memory. And let me tell you, it is highly organized. You have the method area for shared class metadata. You have the heap, which is essentially this giant shared shelf where all your Java objects actually live. But then you have the stock. Now, every single thread gets its own private stock for local variables and method calls.
So, to put that into perspective, if you create an object named Alice, the actual object sits way out in the shared heap, but the reference pointing to it, that stays safely tucked away in your specific thread's stock. Finally, we reach the execution engine. This is the chef actually cooking the meal. Now, our chef has three main tools at their disposal. The interpreter reads the bytecode line by line. It's super fast to start up, but it gets pretty slow for repeating tasks. To fix that, we have the JIT, the just-in-time compiler. It literally watches for hotspots in your code, things that run repeatedly, and compiles them down to hyper-fast native machine code on the fly. And lastly, my favorite, the unsung hero, the garbage collector. It acts as an automated busboy, constantly scanning that heap and just throwing away unused objects so your app doesn't suffer from memory leaks. There is literally no manual memory management required.
Section 4, JDK, JRE, and JVM.
So now that we know how the JVM works under the hood, we really need to clear up this alphabet soup of J acronyms because it gets confusing. On one side, we have the JRE, the Java Runtime Environment. If you just want to run a Java application, play some Minecraft or execute code somebody else wrote, you only need the JRE. But on the other hand, the JDK, the Java Development Kit, is for the creators. If you want to write, compile, and debug Java code yourself, you absolutely need the JDK. Honestly, the easiest way to think about these three acronyms is that they actually nest together like Russian dolls. At the very center, the core, is the JVM. That's the executor that runs the bytecode. Wrapping around that is the JRE, which includes the JVM plus the massive Java standard library. That's all the pre-written code for things like math, lists, and network connections. And then, wrapping around the JRE is the JDK, which includes absolutely everything inside it, plus all the creators' tools like compilers, debuggers, and monitoring utilities.
Section 5, Busting Modern Java Myths. All right, now using what Callaway calls speed to value, we're going to use our new deep understanding of the JVM's architecture to rapidly bust some of the biggest, most persistent myths surrounding Java today. Let's start with the absolute classic. Java is slow and heavy. Now, to build some common ground here, we do have to admit that 15 years ago, this was actually true. Early JVMs had painfully slow startup times, and that garbage collector we just praised would sometimes just freeze the entire application. It definitely earned a reputation for being a massive memory hog. But here is the reality check today. Myth totally busted. Remember that JIT compiler we talked about in the execution engine? Well, modern JVMs use a technology called Hotspot that literally watches your code run and optimizes it in real time. So the longer your app runs, the faster it actually gets. And if you are worried about cloud microservices being too heavy, no problem. Tools like GrailVM can now compile Java completely ahead of time into tiny, native executables. No heavy runtime required at all. It is blisteringly fast. Okay, here's the next zombie myth that just absolutely will not go away. Java is an insecure, dead language, and it's only used for maintaining boring 20-year-old banking software. It's really easy to look at all the flashy new languages out there and just assume Java is sitting in a retirement home somewhere. But again, myth completely busted. Java has remained in the top 3 most popular programming languages for over a decade. It powers massive chunks of Netflix, LinkedIn, and yes, even Minecraft. Startups absolutely love it today because of incredible modern frameworks like Spring Boot. And as for security, well, because the JVM handles memory management automatically for you, you don't get the buffer overflow attacks or the manual pointer errors that absolutely plague languages like C++. It is structurally sandboxed and incredibly secure. So, to summarize our explainer today, the JVM is, without a doubt, the true unsung hero of software engineering. It is the sole reason Java code is infinitely portable across different operating systems. It is the powerful engine that uses just-in-time compilation to make modern enterprise applications run incredibly fast. And it is the ultimate safety net that perfectly manages memory and secures the entire environment. We've covered a ton of ground today. You've just mastered the complex, intricate architecture of the Java virtual machine. And the crazy part? You learned it because we continuously utilized the exact psychological hooks, those context leans, scroll stops, and snapbacks that are specifically designed to hold human attention. So I want to leave you with this final thought. You now possess the communication framework to make absolutely any complex topic utterly fascinating. So what complex idea will you explain next?